Okay, so before I start today's class, I just want to mention that today during office hour, I kind of present some information or some advice or hints or troubleshooting for your homework 0, mostly about homework 0, some about homework 2. So I feel this might be interesting in general to everybody here. So I posted on my YouTube channel. So please go ahead. If you have some question, you can take a look. So just let you know from now on, if I see any moment that's appropriate for me to record my office hour, I will do that, and then I will just post it over there so you can periodically check. And I usually will label about which homework I was talking about. So that hopefully help you to understand what are. I found out that there is only a limited number of issue for each of the homework that very commonly it's like a FAQ kind of things. Okay, so just let you know. Okay, we're going to finish chapter 11 today, and I'm going to move to chapter 12. So chapter 11, I want to summarize with just one slide. Let me see, how do I actually turn off the light here? Should I turn off light here or? All right, anyway, I just. Right. Fine, just leave it like that. Okay, so we talk about a concept class, and we use 4 different classes as an example, which is the one of them, which we go in every single detail, is GPS, which basically say you have the private part, for you to define what information this object try to representing or protecting. Okay, so obviously there are 2 issues you need to worry about. I use both verbs there. One is what kind of information we represent within an object in the digital space. And the second thing is really about protection. So what protection really means is that I want to make sure not just I define the information representing a real world scenario, but also I want to make sure that everybody who is going to use this object in one way or the other, they will follow exactly what I design this information, how this information should be accessed. And that's what I call the second part, the public part or the interface part. So essentially the interface part is restrict how people can access the information within this object, latitude and longitude. That's actually the basic principle. And sometimes we call this principle encapsulation. And what do I mean by it? So there are 2 words. One is data abstraction. So abstractly, I define a concept, a class called GPS. So you see that, okay, this is the GPS is represents some abstract concept. But the other concept, which is equally important, is called encapsulation. So it's related to the second verb, which is protection. So encapsulation means that I want to make sure whoever want to use this object means that you're going to interact with the object, that you don't need to know the detail of the object. Everything about the detail of the object, regardless the data or the internal function implementation, is actually irrelevant to the people who try to use that. That's why I have this interface here, and then you only need to know the interface. In fact, I will argue you only need to know the .h file. For example, GPS.h. You shouldn't need to know GPS.cpp. So remember, we had a discussion about why we want to separate the definition of the object or the class versus the implementation of the class, which is, for example, in GPS.cpp, we see all the detail. So that concept is called encapsulation. You can see that the principle of encapsulation is quite practical for us to engineering the concept, especially object-oriented programming was really designed to enable sharing about information, sharing about program, and such that because I have this abstract interface, is easier. It's not that easy, but it's easier than non-object-oriented programming when I want to exchange some idea. Okay, so that is the most important concept I want you to get from chapter 11. So I expect you to do two things. One, you will be able to start writing a object-oriented program following this principle, and which you will get homework assignment number 3 very soon. Okay, I'm actually in the process of finish that. Okay, so before I move to the next, I want to just, these are the example. By the way, in the textbook, let me see which, in the textbook, they actually using another example called box, which in the chapter 11, it's similar, but it just has length, width, and the height for you to actually be able to calculate, say, the volume of the box. That's just an example. Okay, I want to, yeah, this is just okay. I want to talk about this. This is one particular example. I didn't go through. So in the in the GPS class, you can see that, for example, this particular are the student in the back can see the screen? Is that too bright? Can you see the screen? Okay, all right. So yeah, I mean, from my angle, it looks like a very too bright for me to actually see it. So on top, you can see that I'm using the GPS class. I actually create 2 GPS objects. So class is the master plan about how you can use that class, use the constructor provided by the class to actually create object. So GPSDD is the class name, and then I actually create 2 objects. One is called GPS Davis. The other one is called current. And you can see I'm using what we call bracket initialization to create, for example, the first one is GPS for Davis, which is the 2 double precision number I put there. And the second one is just a current location. So basically, you can see that I'm using ARGV to receive this number, but I actually use a function called A2F. So A2F is another C function, is A2F stands for ASCII to floating point. So essentially, whatever you type in as a string, you say 32.789. That is a string with 6 characters. So A2F basically converted to a double precision. So this is, by the way, the programming, we did this a lot. So we sometimes the program or whatever environment will automatically provide the conversion whenever they actually have no confusion about what you're doing. But in a lot of cases, we have to do this explicitly. We have to explicitly saying that, hey, please convert that to a floating point number. Oh, by the way, just to let you know, in case you haven't done this a lot, you want to do, you can do man A2F. So always in the Unix window, always do man to look at every single function. So you can see that you can have A to F, or you can do A to F underscore L. So it's just a different function that's A to F. L is actually providing one extra parameter, but usually we just do A to F. That will be fine. Okay. So just the takeaway is just do main. Whenever you saw a function that either I use in the class or you actually saw somebody else code, have that, just remember to just type main and then find out all the information. Okay, let me go back to my slide. Let me see if I have something I forgot to mention before I jump to 11. Okay, this is one thing. Okay, so one of the things I want to talk about is the distance function. So last time we talked about constructor, but we kind of very quickly to talk about distance. So right now I want to go a little bit depth into the distance. So you can see that the distance function is trying to compare the GPS. So essentially this one want to say is where you are, which is the current location, and what's the distance between your current location to the location of Davis. So that means you can actually see how far away you are. So that distance function is trying to calculate that. Okay, so this is interesting because typically a object-oriented programming is about a object. So essentially it's object-centric. So we have an object, I want to interact with this object to do something. But obviously here is a little bit interesting because it's involving two objects. And sometimes you will see situations that actually involve multiple objects. So if we actually look at an interface, like this is the interface. Usually we just dealing with one single object. So how do I be able to handle, say, when I want to have multiple objects? In this case, it's actually two objects I want to work together. So let me actually tell you, this is the one way to do it. And then chapter 12, we're going to teach you another way to do it. So one way to do this, when I have two objects, I want to deal with their interaction. The way I do it is passing one of the object as a parameter to another object. So let me actually tell you, for example, I said, excuse me, I still have hay fever. This is a hay fever season. If I forgot to get my mouse mask, and then I got pollen when I walk outside. Okay. So for example, over here, I have a two GPS object. I want to calculate the distance. Unavoidably, with chapter 11, you have to pass the second object as the argument into the first object. And then in the space of the first object, you try to perform whatever the computation involved, both objects. Okay, so in the source code, let me actually just tell you what I actually show you this already, but I want to show you this again. So for example, when I do this distance function, you can see that I actually have an object. This is, of course, it's a class. So it's basically will be instantiate. But the first argument is also an object of the same class. So what I meant here is that I'm actually bring another object of the same type into the object I'm actually currently in right now. And you can see that I'm actually, you can neglect the first function, which is basically compute two pair of GPS location and try to generate the distance and return. But the interesting part is the first four arguments. So the first two arguments is this to the latitude and this to the longitude, which means that the current object, because there is object one, which is the primary interaction to your program, and that is the latitude and longitude, then you have to basically using this to unambiguously to show that that's a pair of address you're dealing with. But then with another object, you see that now this is another dot brought in. So I have another dot get latitude, another get longitude. So in this way, you can see that I'm essentially compute the relationship between two objects in the implementation of the first object. I just brought in another one. Okay, that is a common way to do object-oriented programming when you want to deal with interaction with multiple objects. And of course, there are different ways to handle this. We're going to teach you more, but for the moment, that I just want to tell you, this is a very common way for you to handle this situation. Okay. Okay. I think that's more or less I want to discuss in class for chapter 11, the basic understanding about class and how to use the class, how to use the class to create an object, how to use this class to be able to create multiple objects and let them interact with each other. When I say interact, you can think about a real world implementation. You must have a large number of objects you need to deal with. And in that case, those objects need to interact with each other, communicate, and work on something useful. Okay, any question about this topic so far? Okay, good. Okay, I want to go for the next set of slides, which is this one. So I want to quickly summarize what we have done so far. So this is the target system we try to deal with. This could be a community, or could be a business, or could be some kind of real world scenario that you want to solve. So object modeling essentially look at this particular scenario and decide that how do I actually be able to create a bunch of class. That's actually try to run, because if you look at this, it's really have a lot of objects and how they interact with each other. So that's why we actually define a bunch of class. For example, in this slide, I say you define a box or you define a person, which you define multiple class, just like what we did since last lecture. And then what you did is so far, and then you kind of create both the .h file and the .cpp file. Wow, it got blocked a little bit. Okay, fine. So you're basically using this classes and you define, and then you will be able to just define the private part and the public part. And then you have the CPP part, which is represent the implementation. Oh, wow. Sorry, I want to do this so you can see the whole thing. Yeah, this way is better. I don't want the zoom to block some of the character. Okay, so as we mentioned, you have the H and the CPP and then provide the implementation. And then you have a driver program, the main program. So together with the driver or test program and with the .h and the .cpp file, that you will be able to represent the whole scenario over here. So that's what we try to do in terms of the object-oriented. This part is, by the way, it's called object-oriented modeling. And this part is called object-oriented programming. Okay, they're basically putting together. And well, And the concept I also mentioned so far is called separate compilation. So separate compilation means that you actually compile the box.cpp or whatever person.cpp separately from the main program. So each of the .cpp file, you use the G++ or GCC minus C option for you to compile separately. So with a minus C option, it's going to generate the object file, the .o file. So now I think I better use this one. Otherwise, the student far away might not be able to see this. Make it a little bit bigger. So using the compiler with a minus C option that you can actually get the .o file, which is object, but then you have a bunch of .o file. And finally, with that .o file, you use the linker, which is linking your object file together with the library. A lot of you have trouble linking the library for homework assignment number 0, and you actually create executable. And with that executable, when you execute the program, it's essentially going to represent whatever a emulation or approximation about what's going on over here. So I was talking about 3 steps. One is called preprocessing, one is called compiling, one is called linking. You're probably familiar with compiling and linking for now. So what preprocessing really trying to do is deal with the include file. So preprocessing is trying to make sure you have the include file being included correctly. That's why when you deal with homework assignment number 0, when you compile, depending on where you are, you have to run minus capital I flag. You have to add a minus capital I flag. So the preprocessing be able to find the right include file to be included correctly. Okay, so just this is a 3-step about how to build a program, a C++ program. Okay, so now I can officially get into chapter 12. Chapter 12 is really talk about operator overloading. So I will start using the example. I will use this example. This was the example. I'm writing a program that's dealing with 2 different objects of the same type. Okay, by the way, it's possible that you can deal with 2 different objects with a different type. But I want to start with the easier case, which is dealing with 2 different objects, but they belong to the same class or same type. Okay, so just look at the code. This code is from the chapter 11, the second program. The program is saying that box1 dot compare volume of box2. So let me just parse. Box1 is an object. Box2 is an object. And the member function of box1, which is the class box, is called compare their volume. Okay, so that's essentially the function it's trying to do. So over here, we're trying to see that which box is actually bigger. Which box is actually bigger? Okay, so any question with this piece of code? The syntax, at least the syntax or the meaning? Try to compare the volume of the 2 boxes. No question? Okay. So I'm going to show you 2 different ways. I said there are multiple ways you can have objects to interact with each other. So I have 2 different ways to do that. By the way, the top and the bottom, they're exactly the same. They're exactly the same. But this one, I'm using operator overloading. So instead of looking at one object into the other, I kind of define an operator that's actually have a left operand and the right operand. Looks like this. Okay. So so number one, I want to tell you that this 2 pieces of code they are exactly the same. At least semantically, they are exactly the same. Number two, I want to say, if you look at the code, looks like this. The second way, internally in C++, it actually got translated into the top. It's not saying C++ give you another way to do certain thing. It's basically C++ has a more human readable format to represent the top, which is actually internal. Even you wrote the code this way, but it's actually in the computationally is actually being implemented internally. You don't see it in the top. So that's called operator overloading. Okay, I don't just want to say this, that operator overloading is really for readability. So I want to write the code this way and such that your code will look easy. I mean, by the way, I should have asked you, what's your preference, knowing what we're doing? Do you prefer the code on the top or the code on the bottom? How many of you think that the code on the top is better? Good, good. I like a diversified view on this, because when I say overloading learning chapter 12, I already assume that, oh, we need to do that because it's better. Not necessarily true. Okay, a lot of cases, we always want to challenge the whoever designed the language. I want every single student in this class, try to challenge, even try to challenge your instructor about whatever I said. Okay, I want you to absolutely feel free to do so. Okay, yes.
So if we have another function, let's say is compare mass or something like that, how do you know the larger sign is pointing to the compare volume or compare mass?
Right. So you have to define the function. I guess you have to say, oh, wait a minute. You're talking about this one, yeah, right? That's fine. Exactly. That's the problem with that. That's I will go into. Let me actually show you this as example. You kind of ahead of me a little bit. If I say a person, if I say person 1 is greater than person 2, okay, I mean, let's actually talk about this. Most of you think that the overloading sounds good, right? It's actually not. You have to be careful, okay? That's why I want you to challenge this. If I say person 1 is greater than person 2, what does that mean? It's like what you asked, right? I mean, this could be blood pressure or age or height or whatever, number of hair or EQ. I mean, there are just so many things that you can actually compare between two objects. I mean, when you deal with a real object, when you deal with some simple object, it's fine. But if you want to deal with anything that this might not be really clear about what you're talking about. Okay, so be careful of this mechanism, your textbook, and by the way, most of the textbook, they use one full chapter to tell you the detail about what it is, how to use it, syntactically, what does that mean? But fundamentally, I want you guys actually took away from this class is that, well, I don't have to use it if I don't feel it's actually the right apply to the situation I'm dealing with. So compare two boxes. It might help you to readable. I mean, for example, if this program is in the context of a health domain, when we compare person 1 to person 2, we know it's related to blood pressure. Then that's clear because the whole team knows that this is about somebody's blood pressure. And maybe you say person 1 is greater than person B, it makes sense. But unless you are absolutely clear, unambiguously knowing what is the comparison meaning is, sometimes you have to think twice. So that's why I said it's always about readability. It's not about convenience. Oh, you can actually write a code in a way that's actually doesn't look so awkward. No, sometimes you have to understand the fundamental principle of programming is how do you unambiguously convey the idea about what you want to convey. Otherwise, your program will have trouble because later you misunderstood the meaning of that particular piece of code, and then the meaning is really confusing over there. Okay. All right, so now let's actually take a look at the detail about, okay, knowing this, I would call it a pitfall about this mechanism. It looks nice, overloading. It makes the program more looks like your old style C program. Instead of using this compare volume, compare high blood pressure, compare age, you use that. But now I'm going to actually tell you how overloading is really done. Okay. So in order for you to do that, that's a syntax. You actually already saw this example when I show you the person class. So essentially, in the definition of the class, I have to define this operator called greater than. I have to define that. That's why in the function, I have to say operator greater than. And then I basically put the parameter is another object. Okay, so box to another box. And then inside this object, I set volume greater than another box volume. Okay, so that is essentially what we're talking about, greater than in this context. Okay, so that's, you have to look at the code to understand what it is. So let me actually go back to the example I showed you the other day. Yes. What? Oh, constant means that you cannot change it. Right. That means, for example, sorry, I bring the wrong file. Okay, so, okay, that's a good question. So the question was, why I want to have a const over here, right? I have a const, that's your question, right? Oh, this one const is the same thing. I want to tell you its meaning. I will show you first this const, and then I will show you the next const. Okay. So this const means that when I pass this object, you see that I pass this object with an and sign. That means I'm passing this with what we call by reference. You asked that question, right? About how do I actually pass a reference in C++? You ask that M, so you don't have to make a copy. You're pass the same thing. But I want to make sure that nobody inside that object is actually going to modify the value of the box. I'm just showing you to do a comparison. I want to avoid copying, but I don't want you to change my content. That's why I actually do a const on this object. But this const is basically saying that this whole function, they're not going to change this object as well. Meaning that when you do a comparison, you shouldn't change the any value. I'm just doing a comparison, is a logical return, and this shouldn't involve. So I kind of enforce it that nobody can change anything inside. That's why I have those two consts over there. Okay, good question. Okay. So let's actually take a look at this code. Let's look at person.h first. And then simultaneously, I look at person.cpp. So let's actually look at the interface of person, which is the .h file. After the public par, you see I have operator. Operator, that's the keyword. I have equal. So equal is basically a equal comparison between any two object or any two number and things like that. So I essentially overwriting that particular operator called operator equal. That's how I define. And then I basically define it this way. This means that I actually going to compare this person. Remember, this is actually definition of the person class, which is this person against another person. So two objects, I want to do a comparison, and I want to use operator equal. So I have to use the keyword operator and put this there. And then the return value of the operator equal is a Boolean. It's true or false. That's a typical way we define this. Okay, so let's actually look at the implementation of operator equal. Here. Okay, this piece of code is how I implement operator. You see that their function prototype is the same as this function, right? Okay, by the way, I want to ask you a question. I might have skipped this earlier. If I use this term, function prototype, what does that mean to you? If I use this term, let me write it down here. What's the meaning of function prototype? Have you heard about this term? Okay, a function prototype is representing what is this function in terms of its type in both the argument and the return type. So in this case, for example, what is, pretty much is everything except the function name is called function prototype. So for example, this function operator equal, what is the input argument? The input argument is a person object, right? It's a person n, so it's a reference to a person object. And then what's the type of the return is Boolean. So essentially the function prototype for this particular function is input argument, one argument, and that argument has to be a person object. And then its return type is a Boolean. So why is function prototype significant? Because when I decide whether that particular function, this particular function is actually matching exactly with this declaration, then essentially I'm looking at the function prototype. It's looking at whether the input argument is 1, and that argument is the same type as I declare here, and then what's the return type? If they are all matched, then essentially they are actually the same function. So I can link, the linker can actually link to that. That's function prototype. Okay, I'm going to test your programming language knowledge a little bit here. In C++, I'm not sure about C. I have to try it, but I'm going to ask you for C++ directly. In C++, can I have two functions with exactly the same name? Can I do that? Okay, I know some of you probably say yes. The answer is yes, okay? The answer is yes. You could have multiple functions, they have different functions with exactly the same name, okay? The example you already see is what? Constructor, right? Constructor have a multiple of them, the same name, but what's make it different? How do I, or the compiler or the linker knows which one you're calling is based on function prototype? It's based on the number of argument, the type, and the return type. Yes. Right. Exactly. You're right. Yeah. So essentially, when you have two different functions with the same name, they must differentiate somehow in the function prototype. Either the number of arguments are different, the type of the argument. One is integer, the other one is a floating point, or the return type is different. So any of this function, that's why it's important to understand what do I mean by function prototype. Function prototype means all the information about the number of argument and the type, data type of each of the argument, and also the return type. The return value, what's the type of the return? The whole thing added together is a function prototype. So essentially, I'm saying that function prototype basically cover all the information except the function name. The function name is not covered by the function prototype. Okay. So with that, that's actually just tell you that you have to see that, oh, this one actually matches this well because it actually have exactly the same function prototype. Okay. So inside here, you see that what I really did for this piece of code. Oh, this, by the way, this code is bogus. Realize I must actually did something which is change the code. So the code I released to you is actually incorrect. Why is this incorrect? Right. So I'm actually do the wrong thing, right? One is the name of the person, the other one is social security number. So I could either get this one, the correct way is sorry, okay, fine. The correct way is either I have three different versions. The first version is get. Okay, that's one way. The second way is just basically say name. And the third version is, no, I want to do this. The third one is like this. Okay, you see I have a 3 implementation over here. They could actually fit into the operator overloading. This was related to why I said earlier, sometimes operator overloading is a bit confusing because I can actually compare two people, are they the same based on only the name, or based on their social security number, or based on both name and social security number. So I want to actually test you. Which of the 3 options you think is better? I mean, given the current society in United States, if you're going to implement, which one is best? Yeah. The first one. Okay, we have a 1 vote for the first one. Anybody vote for the second one or the third one? You want number 3. How about you? One number 3, one number 3, one number 1. Okay, anybody? You want number 3. Okay. You're a minority, right? I'll go with you. Okay, so 2 versus 3. You have to help me to find the 3 guy. Okay. So please tell me why you think number 3 is better. Yeah, in the back, and then you. Can you speak louder? You said social security number 1.
Social security number is and you have people with the same name, so if you check both, they're the same.
Okay. Okay. All right. I got your argument. You. How about you? Yeah.
I was gonna say the same thing.
Okay.
I would argue for the first one that the social security number is unique to a person, and you just have to compare them to see if they're the same person. The name doesn't matter. If you just assume that a person is their number, then just the name is just a second identification that is not unique.
Okay.
So it's better to just compare the unique ones.
So you're with him.
Yeah.
Okay.
I think number one is better because you can legally change your name. And so if
That's
you're
true.
comparing your name, like with the time before when you changed it, it'll say you're a different person, even if you're the same. So you only need the social security number to be more accurate.
Yeah, you guys can argue the whole weekend, okay? That's your assignment. All right, I'm going to conclude. Yeah, you want to say something? I'm sorry.
I can tie this back to the whole object-oriented modeling paradigm where let's just if the object maintains the integrity of its data members, then it's assumed that the name corresponds uniquely to an SSN. Thereby, you could use either one or two to prove equivalence. If for some reason that integrity does not hold, then you need to verify both the name and the SSN between two person objects.
Okay, by the way, there is no definite good answer or bad answer. I mean, I personally prefer is actually number two. Because I feel I will never give a program my social security number. Should I include that? All right, so that was a trick, but I want to actually say why I like social security number because it's I think you mentioned that people can change their name, right? Number one. But on the other hand, social security number can be compromised. So therefore, having social security number sometime if with a name, then you can have like a second thing to kind of double check in case your information is compromised. But anyway, okay, you guys have a good weekend. We're going to continue with operator overloading on Monday. All right.